Okay, you want to stay flexed on one side, that's your flexion withdrawal, but the opposite lower extremity you want to extend so you can stay stable and upright. Does that make sense, everybody? Okay, moving on. This was the end of the spinal cord overview. Okay, now we're going to look at the somatosensory tracts. Somatosensory, again, what does that word mean? Yeah, sensation coming from the body. All the different sensations that are coming from the body. Okay, and specifically, we're going to look at those two tracts that we talked about before: DCML and STT, spinal thalamic and dorsal column medial meniscus. And you're going to learn why it's called dorsal column medial meniscus. It's pretty cool. All right. Okay, so everybody's here. This is my rendition. I always think it looks like an alien. Somebody said an alien baby. AJ said an alien baby. I think alien. It looks like an alien to me. So hopefully you're pretty used to seeing. This is your frontal section, right? And this is going to be your cortical region. It's cortex. Okay, and then just to make it less crowded, let's go ahead and I'd like to put one track on one side and the other, and you can see the changes. There's a few differences. So if I draw a midline here, it's going to be easier to see when things cross over. Okay, basics. What's this structure in here? It's a bunch of nuclei. That's your thalamus. Okay, and then basic parts of the brain stem. The uppermost part is your midbrain. It houses the cerebral aqueduct and the red nucleus that we've talked about previously. And then you have your pons right here. And then an important player that we're going to learn about today. We're going to learn some stuff of what happens in the medulla and some of the nuclei that it houses. Bless you. They're going to be involved in relaying somatosensory information to the CNS. Okay, now let's go ahead and use, I think, let's start with the spinal thalamic tract. So we have, if I want to draw the spinal thalamic tract, let's start here with my pseudounipolar neuron cell body. Okay. And then this resides in the dorsal root ganglia, sends out an axon, and then here are the dendrites for my pseudounipolar neuron. And this is going to be the spinal thalamic tract. Also STT. So, what kind of information is the spinal thalamic tract responsible for carrying into the central nervous system? Does anybody remember? Good. Crude touch? Yes, crude touch. Awesome. Crude touch, pain, and temperature. So it's really very primitive tract. Most primitive. So we come in, and your dendrites are picking up this information from the spinal thalamic tract. The axon comes in, and it synapses immediately in the spinal cord. Okay, this is a great big overview, and just comparing the different tracts. Synapses immediately with the second order neuron. Again, this is the first order neuron here. In the dorsal gray horn, in a very special space we'll talk about later, there resides the second order neuron. Okay, first order neuron comes in, the dorsal gray horn synapses with the second order neuron. Does anybody remember what happens with the second order neuron? It does something special. Always decussates. Good. Goes to the opposite side. Perfect. So that's how it gets to the opposite side. Okay. Okay, spinal thalamic tract then makes its decussation or gets to the opposite side at the level of the spinal cord. Whatever level it is, it crosses over immediately, and then it travels up through the spinal cord, through the medulla, through the pons and midbrain, and then synapses here on a third order neuron. Okay, the third order neuron resides in the thalamus. Here's your third order neuron. Okay, and then from there, your third order neuron sends out an axon specific for the somatosensory cortex. Okay, it's going to be, so if the information is coming in from upper extremities, it's going to go to the part of the somatosensory cortex homunculus specific for upper extremities. It's going to go for lower extremities. It's going to come in down to lower, at the lower spinal level, travel all the way up, and then go to the part of the somatosensory cortex that's specific for lower extremities. Okay, everybody got that? And this is your spinal thalamic tract. Broad overview, we're going to go into much more detail, the spinal thalamic tract. Now, the next one is going to be your DCML. And like I said, I'd like to start over here on this side with the DCML information coming up. So we have our first order neuron cell body sitting there in the dorsal root ganglia. Yes, thank you. With the dendrites. Okay, so this is going to be our dorsal column medial lemniscus, or DCML. Okay, that's your DCML tract. Looks a little different. Now, what kinds of information does the DCML carry up into the fine touch? Conscious proprioception. So it's going to be fine touch, just basic proprioception. It's just going to be conscious. So the conscious means you're aware of it because it's going to go all the way up to the brain. Proprioception and vibration. See that? Okay. Each carries three different things. Okay, DCML is a little bit different. Talk about, and we'll go over this in much more detail. But what happens is this is sitting here as your first order neuron. Okay, your first order neuron dendrites pick up this information from the environment. A neuronal cell body located in dorsal root ganglia. Axon comes in at the level of the spinal cord, wherever it's picking up information from. And then what happens is it goes up to the level of the medulla. Okay, at the level of the medulla, it synapses on special nuclei here in the medulla. And these are your second order neurons, second order neuron cell body. Okay, your second order neuron in the medulla. At that point, it's here, and then it crosses over, decussates to the other side. Second order neuron always crosses over, and then it travels up. We'll find through a special tract. Second order neuron goes all the way up to the level of the thalamus. Synapses with your third order neuron. And then third order neuron sends out axons to the postcentral gyrus or somatosensory cortex to convey that information up to the central nervous system. Somatosensory. Yep, somatosensory is postcentral gyrus. And the parietal lobe. Motor is in the frontal. Somatosensory is in the parietal. Any other questions? But look at it. What I want to do now is these are the two somatosensory tracts that we're going to talk about this semester. What I wanted to do is just take a minute and compare and contrast to see what they have in common and how they're different. Can anyone tell me a way that they're different? Sorry? Yeah, they decusate. They're unique. And so we have a unique decusation. Okay, so DCML decusates in the medulla. And then the spinothalamic tract decusates in the spinal cord. SC for spinal cord. Good. Anything else? Whether they're unique? How else are they unique? Thoughts?
Where the second order neuron is located.
Yeah, where the second order neuron is located. Where decusates, so unique in decusation and unique in second order neuron location.
So the medulla would be more critical on DCML.
Not more critical. It's just if a person has. So the big picture is going to be if a person has an issue below the level of the medulla, STT is. Patient's going to lose pain and temperature on the opposite side, but they're going to use the DCML information on the same side. If that makes sense. We'll go get to that. Yeah, Pat? Yep, they carry different modalities. Right, and they're unique. They carry different modalities. And hopefully by the end of the class, you'll see what I mean about patient presentation. That's kind of putting it all together. That's getting ahead of us, but that's okay. Okay, how are they similar? Any thoughts? How are they similar? How are they the same? Yeah, three neuron system. Good. Any other way that they're similar? Yep. I'll just say some SSC, somatosensory cortex. Great. They both go to the somatosensory cortex. Any other place they both go? Thalamus. Yeah, both go to the thalamus. Good. Any other similarities? We talked about one earlier. How about the second order neuron? Yep, they both cross over. Second order neuron always crosses over. The second order crosses over or decusates. We got third order neuron synapses. There's one more. The last one I think would be that the first order neuron is a pseudo-unipolar neuron. Hopefully that word's getting more familiar to you. So the first order neuron is pseudo-unipolar. Okay. That's it. Just a comparison and contrast. Thinking about these two things and how they're similar and how they're different. Questions about these two? Sort of, like I said, there's always a lot of review to this, and I think repetition helps to learn it as you go. So, if there are no questions, I will go ahead and move on to the next one, which is, sir? Did somebody say something? No. Okay. We're going to start with dorsal column medium lemniscus. Okay. What we're going to do is go into the DCML in, more detail than you probably ever wanted to see, but oh well. Hopefully it'll help you learn. So this is going to be the DCML, and what I've done here is I have two spinal cord cross sections by looking at the DCML, and what I'd like to say is that this one on the bottom is below the level of T6. So thoracic level 6, back up in here. And then this one is T6 and above. Okay, so two different sections. So I realize there's a lot of in between. There's a lot of above, but I just chose two different sections. One's below the level of T6 and the other's above the level of T6. Okay, thinking about this DCML, we talked about a tract last week. Does anybody remember below the level of T6, if I had to draw in this tract right here, anybody remember what the name of that tract would be? Yeah, that's fasciculus gracilis. Great. So, label that. It's going to be your fasciculus gracilis. Okay. Not sure if I talked about the function of fasciculus gracilis or not, but as we've seen previously, the first order neuron sitting there in the dorsal root ganglia, okay, and it's going to receive information from areas below the level of T6 spinal vertebral level, and this is your first order neuron, so this is going to be DCML, so it's going to be fine touch, vibration, and proprioception information. It's from the lower extremities. Okay, everything below the level of T6, which is going to, I want to think about the lower extremities. So this DCML below the level of T6, think lower extremities. First order neuron sitting there. Okay. Axon comes in for DCML, comes into the dorsal great horn, and then immediately starts to go up on the same side, ipsilaterally, travels up through the fasciculus gracilis. So fasciculus gracilis, the tract, carries information about lower extremity, fine touch, proprioception, and vibration. Okay. So really, as it travels up, I'm just going to represent this to it's traveling up through the same tract and then just keeps going up on both sides. Does that make sense to everybody? See what I'm trying to do? So the information comes in here through the dorsal root ganglia, goes straight up. Okay, and then to make it consistent, here's the same thing coming on the other side. So fasciculus gracilis carries lower extremity DCML information, fine touch, proprioception, vibration. Travels all the way up through fasciculus gracilis. And that's below the level of T6. Questions about that? Okay, and then we have the next one. Above the level of T6, you not only have this fasciculus gracilis, you're also going to have, what's the one right next to it? Anybody remember? Yeah, that's fasciculus cuneatus. Okay, fasciculus and gracilis and fasciculus cuneatus represent the dorsal columns. They are the dorsal columns. Fasciculus, C-U-N-E-A-T-U-S, fasciculus cuneatus. Okay, fasciculus cuneatus does not exist below the level of T6. It's just the upper stuff. Okay, so a similar thing happens only for the lower extremity. So here's your first order neuron sitting here in the dorsal root ganglia. Dendrites are going to pick up information, DCML information, which is fine touch, vibration and proprioception, from upper extremities, mostly. Get a little bit of trunk in there. And what happens is that first order neuron comes in through the dorsal great horn and then immediately travels up through the fasciculus cuneatus tract. And this is just a view of the DCML pathway, and it's much more complicated than spinal columnar tracts. That's why I like to do it first. This is just the level of the spinal cord. So first order neuron below the level of T6 comes in and travels up fasciculus gracilis. First order neuron above T6 and above comes in, travels up through fasciculus cuneatus. Gracilis has lower extremity information in general. Cuneatus has upper extremity information. Okay. I don't remember. Did I talk about the anterior spinal artery last class? No? Okay. Well, it was a good time to pop it in there, but I didn't. Let's go ahead and say the anterior spinal artery resides in this space. Does anybody know what this space is called? A little fissure? Anterior median fissure. Good. So, because it's anterior or ventral, it's in the middle, so it's median, and it's a big thing, so it's a fissure. So this is going to be your anterior median fissure. And this is your anterior spinal artery. Remember the anterior spinal artery? Remember that coming off the vertebral arteries, going up on the way to brain circulation, posterior circulation of the brain, the vertebral basilar system. ASA comes off both vertebrals and then comes back down to form a one ASA, and this is where that ASA is going to reside. Okay. The important part about the ASA is that it is responsible for supplying blood to the anterior 2/3 of the spinal cord. As it turns out, it supplies blood, and I'll put it in, everywhere but the dorsal columns. Everywhere but the dorsal columns is going to supply blood to the anterior 2/3. Of the spinal cord. So if somebody has a stroke on the anterior spinal artery, which is the main artery that's going to have a stroke, that's going to be affected by a stroke, it's the most we'll see. What is going to be preserved in that patient population? What isn't going to be affected? What's the only thing that isn't going to be affected? As far as patient presentation, what are they going to maintain? Function?
Or sensation.
Yeah. What kind of sensation? Are they going to be able to feel pain? No. No. They're going to maintain only this information, DCML upper extremity and DCML lower extremity. So they're going to have fine touch, proprioception, and vibration because this wasn't touched. Does that make sense to everybody? You see that? So if you have a patient with an anterior spinal artery stroke, they're going to lose all motor function. You'll see they'll lose ST2 function too. We'll talk about that later. But everything is gone except for that dorsal column system, and that's fine touch, vibration, and proprioception from upper and lower extremities. See that? Okay, let's throw that in there. Let's move on. Let's move on to the level of the medulla. Oops, hold on. So this is another one that I think looks like a little alien. I'll go back and label some of this. So this is going to be your spinal cord. So what I've tried to do is just make this a continuation of this. So as we're traveling up, this piece here is traveling up, and this information is going to just travel up through the spinal cord. That's what that is. Okay, and then here we have the lowest level is going to be your medulla, and then your pons. Does anybody remember which cranial nerve this is in the midbrain? Yep, third cranial nerve. That's going to be ocular motor. So cranial nerve 3 in the midbrain. And then here's my nice landmark, I think, is going to be your, what's that portion of the ventricular system that travels through the midbrain? Anybody remember? You got it, cerebral aqueduct. Good job. So this is your cerebral aqueduct. Okay, do I see where we are? And this back here, so you're looking at the front view, this is going to be my cerebellum. Colors are this color. Okay, I'm going to try and keep consistent with my colors if I can. So the fasciculus gracilis, I have, let's go ahead and label. I always like to draw dots right down the middle so we can see that decussation really clearly. Okay, so this would be the right side of the body, and this would be the left side of the body. The cerebellum's in the back. So, does anybody remember which of the columns is more medial? Is it fasciculus gracilis or fasciculus cuneatus? Gracilis is more medial. Okay, so let's go ahead and have gracilis coming up here more medial. So I'm trying to, I think this is the same color. Coming up here, it comes up to the level of the medulla, and as I said previously, it's going to decussate. I mean, it's going to synapse on a second order neuron. So, thank you. Okay, so this is going to be fasciculus gracilis. Okay. And then the one that was more lateral is then going to be fasciculus cuneatus. So these are just tracts. It's the name of the tract, just a bunch of white matter axons traveling in space, three-dimensional space together. Okay, so we're continuing on from below. We've come up through the spinal cord, and we've gotten to the level of the medulla. And as I said before, the DCML tract, when it gets to the level of the medulla, what's it going to do? Does anybody remember? Synapses, right? It's going to synapse on a second order neuron. So that's the first order neuron. Here's my second order neuron. And synapses in a special nucleus. So the fasciculus gracilis, here's the fasciculus gracilis in this lighter green color. It synapses on nucleus gracilis. Any guesses on where fasciculus cuneatus synapses. That's it. Nucleus cuneatus. Okay, and these are nothing more than nuclei that exist in the lower part of the medulla, or the caudal part of the medulla. Okay, and once, is this still working? Oh, running out of battery. Boy, it's not a good day. I'm apparently out of battery, so I'll just try and speak up. Once we get to the level, once we synapse the first order neuron, this is still a first order neuron. First order neurons, so first order neuron from the upper extremity, and then the first order neuron from the lower extremity. All right? And we synapse with our respective nuclei, nucleus gracilis and nucleus cuneatus. What happens is that they're going to, the second order neuron is going to decussate. So we're going to decussate here to the opposite side. Both of us, we're going to send out axons. Both the nucleus gracilis and the nucleus cuneatus are going to send out axons. We're going to decussate to the opposite side. Okay, and then once they decussate to the opposite side, they're going to travel up through a special tract all the way through the midbrain. Both of them are going to do it together. So now these two separate tracts are traveling as one tract. And when we look at the brainstem, we're going to be able to see the name of that tract. And the name of that tract, or what that tract is, I'll designate it. This is one tract traveling up together, like a little cylinder here for the tract. So we went from the dorsal columns. Yeah? Move it down. Down. There you go. Just all the way up. We're going up through the midbrain, just traveling all the way up. Now the point is you've gone from the fasciculus gracilis and cuneatus synapsing with their respective nuclei, and then they decussate here, and then they travel up as one tract. So there's no more two tracts. You become one tract. So you went from the dorsal columns to one tract going up through the brainstem. Any guesses as to what that tract is called? Dorsal column, medial lemniscus, that's it. This is your medial lemniscus. This tract right here, this bunch of axons traveling together, is called your medial lemniscus. And that's the dorsal column medial lemniscus. That's where the name comes from. So in case you have trouble remembering medial lemniscus, just think DCML, dorsal column medial lemniscus. So guys, see that, understand the concept. So now you're traveling up as one tract as opposed to two separate tracts. So now your upper extremity and lower extremity information are traveling up together. They're no longer separate in two separate tracts. There's one more piece of information that I need to talk about. Whenever there's a decussation, you'll find out that decussation is called something. When these fibers from nucleus gracilis and nucleus cuneatus cross over, that decussation, these fibers are called internal, INTERNAL, arcuate, ARCUATE fibers, FIBERS. So your internal arcuate fibers. That means nothing more than that is the decussation, or the fibers that are decussating from one side of the medulla to the other. They're just called internal arcuate fibers. And to finish off the pathway through the midbrain, they travel up together through the medial lemniscus, and we'll look at what happens with the rest of them in a minute. Questions? Yes, there.
So is the internal arcuate fibers, is that like another tract, or is it just the name of it?
That's the name of the appearance of the white matter crossing over to the other side. Okay, kind of like the motor system has pyramids. This is internal arcuate fibers, what they're called. And SCT will have its own. Tyler?
Is it only internal artery if the decussates in the middle, or what happens if the decussates in the spinal cord?
It won't decussate in the spinal cord. STT will decussate in the spinal cord, and it's called something different. So internal arcuate fibers are specific for the crossing over of the fasciculus cuneatus and gracilis from the nucleus gracilis and cuneatus at the level of the medulla, and it crosses over. Those are called internal arcuate fibers. Any other questions? Okay, let's go ahead and take a 10-minute break.